Hello, hello. Hello, Internet. Happy Monday. Happy Monday. I'm with my good friend Matt here. How are you, sir?
I'm doing pretty good. It's good to be back at the user group.
Yeah, absolutely. All right, folks. I don't think it's morning anywhere, is it? Unless like it's super early morning, maybe in the APJ areas. But good afternoon, good evening, wherever you might be from. Thank you for joining us here at Coded Live. I'm your host, Sam Basu, and if you join us for some of the streams throughout the week, this is a very different one because this is actually a user group that we used to meet in person. And the world kind of changed a little bit under us, but hey, at least we get to hang out in person. So I'm going to be your host, and this is a user group meeting, so things are a little different than just you watching me code and fail all over the place. This is a little bit more formal. That's why we get good speakers like Matt to come and teach us stuff. But anyways, this is the Columbus App Dev User Group. We used to meet in Columbus, Ohio, and we haven't in person in the last year and a half now. So we genuinely miss hanging out. Like, this is the time where we used to have pizza before the user group. As a family, we try to coordinate pizza nights, but it doesn't always happen on Mondays. But hey, we're here. Matt is here. I will let Matt introduce himself in just a second. So why don't I move some screens over and do some housekeeping. All right. And if I can share my desktop. Just to kind of set the context for everyone who is joining. If you're new to this game and just joining our user group for the first time, let's make this full screen if I can. There you go. So welcome, folks. This, like I said, is the Columbus App Dev User Group. We have been running for quite some time now. Matt, you might remember, like, we started with like Windows Phone back in the days, and we did XNA and XAML, all the good stuff. And we have evolved. We were the Windows group for some time, and then we said, just call it App Dev. It doesn't get any more generic. So
yeah, Sam, I was actually just reminiscing. My first user group talk of any sort was at the Windows Phone user group 12 years ago or so. So yeah.
Wow.
Yeah.
So yeah. We are a little old, don't count us against us. But hey, we are still out there. If you want to come and join us, tell your friends. They can find us online on our website. We are on Meetup, we are on Twitters, and we meet right here online. Now, this month, and actually it might happen to be next month as well, we had a scheduling conflict last Monday. So this is actually the fourth Monday. But we are right here on Twitch. And for the folks who are joining, who are, who used to come physically to the user group, we do this talking for about an hour to kind of get the group going. And then we kind of hop offline and just hang out in Teams for a little bit and just do some chit chat. So these are some of the sponsors who have always supported us. We can't give out physical swag anymore, but eventually we'll get back to in person. Sometime. We always like to highlight some of the things that are going on around us or things that are coming up in the horizon that are relevant to developers. This is our sister user group. This is the Columbus.NET user group, and they meet fourth Thursdays, which this is the fourth Monday. So they're actually this week, this Thursday itself, and it looks like our good friend Chris Woodruff is talking Entity Framework, EF. I know, like, Matt, you have done some EF as well, maybe in your days, but yeah.
Yeah, I'm actually one of the organizers for that group too. So
there you go. Sorry, who am I preaching to?
Oh, you're fine.
So there you go. So that's this Thursday, folks. If you have time, just tune in right here, 6 p.m., 6 to 8 p.m. Eastern time on Twitch. All right, so a couple of big things coming up, and I think a little bit of excitement around the horizon. There has been some troubled waters as well in the .NET space of late, but it's all good. So .NET Conf is the big conference that celebrates all things .NET, from Microsoft, and then they have a lot of community speakers as well. So it's like 3 days of content nonstop, streamed for 72 hours straight. And this year it's happening November 9th to the 11th, which is going to see the launch of .NET 6. And the day before that is going to be the launch of VS 2022, which is pretty exciting for the 64-bit support and all the good stuff. So tune into that if you have the time or if you have interest. That's early November. We do partner with this company that puts together VS Live shows, and they're all over the country. Again, They haven't been doing a lot of in-person things. It's been a lot of virtual, but they are slowly crawling back, just like everybody else. We are seeing the light at the end of the tunnel, hopefully. So VS Live is coming back, and if you do want to go to one of their events, you just have to drop us a line, and you get a big discount. The next thing they're doing is in Orlando, which is again mid-November, kind of right after .NET Conf. A lot of Microsoft speakers, a lot of community speakers, so should be a good time. But within the realms of the safety net, and everyone's trying to be very diligent. More things coming up. This is Dev Intersection, again, catering purely to developers. This is pretty much all week, like 3 days of workshops and like 2 days of conference talks, 100+ speakers, lots of folks that you might know. So if you want to get out of your pandemic mode and start going to real life conferences, they're happening. But again, everyone, I think, should have the right to do what is right for them. So take your time, and then whenever you're ready, stuff is starting to happen. All right, so next month we have Mr. Dave Giard, who's an old friend of mine. He used to actually live in Columbus. And now he's moved off to Michigan, which is, well, actually in Chicago, but he's originally from the Michigan area. Has got his 2 sons through college in Michigan, and just an all-round wonderful guy. And he's going to talk about data visualizations, or maybe, he's also doing some fun stuff with Azure. So he's actually enjoying a vacation in Croatia. So I didn't want to mess with him to say, what are you going to talk about? I'm like, okay, do your thing, and then once you come back, we're ready for whatever you want to speak on. So that's coming up in November. And drum rolls, we have Mr. Matt Eland, and Matt's a good friend. Like Matt said, he's been been a participant and a speaker at our user group for like 10, 12 years now. I remember the days where Matt used to write like Windows Phone apps left and right. He was prolific. And, here we are. Matt's a phenomenal speaker, instructor at Tech Elevator, and you are here to talk about app architectures. And I'm very excited. I'm actually excited to learn about all the stuff that you have to say and how to scale things. So that's it from me, and I will give you the floor.
Thank you, Sam. It's actually kind of funny that David is speaking next month. I was just corresponding with him because we're both giving code visualization talks at CodeMash. So,
that's funny.
Yeah, small world.
Yeah.
Thank you, Sam.
And I should start listing out CodeMash as well.
Yeah.
So for folks in the Midwest of the Americas, we have a thing called CodeMash that happens in January in the middle of winter time, but it's a big water park, so you can be in shorts all week long. And that thing is happening in person in January. And Matt, you're going?
Yep, I'm giving a pair of talks, one on data visualization and another one on data science. So
wonderful.
Yep.
I'll be there as well. So yeah, glad to see things are slowly coming back to normalcy. So all yours, sir.
Thank you much. Happy to be here. Like Sam said, I'm Matt Eland. I'm an instructor up at Tech Elevator in Columbus, Ohio. Talk a little bit more about what we are and what we do in a second. But before that, I spent probably 15, 20 years in the software development industry, working for smaller organizations, building software as a service. So kind of building new web applications, scaling them up in terms of users and capabilities, getting acquired, reacquired, things like that. And so that's kind of how I built my career around things like that, particularly with .NET and JavaScript technologies. So it's a little bit about my background. But like I said, I'm an instructor now at Tech Elevator. I found I really like teaching. And so I get to spend 3 cohorts a year teaching for 14 weeks, where I get to help people learn either Java or C#, databases, really full stack development, JavaScript, etc. I got to teach APIs today, and I love me some APIs, so I'm a happy man today. But we're a really good program. I definitely recommend you check us out. But this talk is actually a result of all the wonderful things that I wish I could teach our students, but we just don't have time for in 14 weeks. So all the things that I wish that somebody was around to teach me about how we scale applications and how we respond to growing user counts and the various options that we have.
So before you start, Matt, I know like this is what you do for work, but can I just say I appreciate anybody who's trying to teach, because it seems like in our industry, like we have kind of relegated the teaching part of it to the back seat, like, and that's kind of how we should be driving. Like, we don't often think about, like, new folks coming into the ecosystem. I was having conversations with folks who are wanting to kind of give back to the community and kind of going back and doing like a little adjunct role for a few months, trying to inspire the upcoming folks. So we really appreciate what you do here.
I will tell you, it's the most fulfilling and most demanding job I've ever had in my life. And I did not expect to do it before 5 years ago. So
there you go.
But enough about us and how awesome we are. Let's talk about scalability, because that's hopefully why you're tuning in today. So my goals for you today, as I'm going to give you a very generic talk, giving you a lot of introductions to new things. I'm not going to go in depth. There's not going to be any coding or live examples to follow along. But my goals for you are that you're going to learn something hopefully a little bit new, that you're going to have a deeper understanding of the basics of application scalability, enough to have a conversational knowledge of it, be able to understand what your coworkers are saying or reading articles or things like that. And I want you to understand some trade-offs, because there's so many different ways of building applications, and all of them work if you do them right, but not all of them are right for every organization and every team at every stage of their life. So these are kind of what I want you to get out of this talk today. But let's talk about what we're going to be going over. So we'll start with just kind of a generic introduction to what a modern application is. I'll talk to you a little bit about how we might scale the application or web server, the things that are entailed in that, and scaling up and scaling out. We'll move on to talking about scaling the database aspect of your applications, because that becomes a very important component once you hit a certain size. And then we'll kind of close with some advanced concepts, things around microservices, CQRS, things of that nature. Some more advanced things. So as we're going, Sam's going to be watching chat for me, etc., to highlight any questions that we might have come up. Please put them in there. He'll interrupt me at the end of every section, and we'll kind of cover other things we can. I should say that I'm a generalist, and some of these things I'm talking to you about, especially once we get into the advanced stages of things, I don't have deep experiences in myself, but I'm happy to share the knowledge that I do have, and I'm sure Sam's knowledge complements mine just fine. And we'll close a little bit today with some guidelines that I would recommend for you as you're getting into these concepts. So when we talk about an application, let's talk about what we're talking about there. So usually you're going to have some sort of a client application, whether that's a web application or a mobile phone or a native Windows application or something like that. And that's what the user is going to be interacting with. And you might have a lot of these going on at once. And these are all making web service calls to some sort of a centralized server that can take that response via an API, respond to it in an intelligent way, and spit back a response. Now, typically, these servers need to use some sort of a SQL or other database technology to interact with the data that's stored and to update that data potentially. But these are the major components that we have in a modern web application. And all of these things must be scaled kind of differently. They have different scalability concerns. Now, when I started doing development, servers looked kind of like this. You'd have some sort of a server, like a physical box in a closet or a data center or something, and it had some sort of an operating system on it, and it had your application. You'd configure your application to work exactly the way you want it to. You'd set whatever configuration and logging settings you needed, and that was fine. If your application needed a little bit more performance, you had to upgrade the server. You had to put in more memory or processing power or whatever it might be. Sometimes you might be tempted to put multiple applications on a server, but that never went well because they'd be competing for the same processor and memory resources, etc. So this is sort of the traditional model of a server that we had, and we'd often have multiple dedicated machines to run different applications that your organization might need. Then we said, well, wait a minute. It kind of sucks that we can't really share the processor or memory efficiently. So what if there was a way to sort of partition this machine? So we still have a really big server, but now we're going to run multiple things on there and sort of allocate different portions of our processing and memory power to each application. And so we introduced this idea of a virtual machine. where you have an operating system that's running what we call a hypervisor, and that's able to run multiple virtual machines inside of your server. So a virtual machine is pictured here, but it's basically an image of Windows or Linux or whatever it might be that's just running on your host operating system. So as far as this image of Windows is concerned, or Linux or whatever it might be, it's a normal instance running on its own machine. It doesn't know that it's being hosted on a hypervisor. And you can actually create these new applications pretty quickly by having like a template image that you can use to create a new instance of an application. And you now have one really big server that can handle a lot of smaller applications and keep them isolated and determine what percentage of the CPU and memory each application should have. So we added some complexity in order to share our larger servers with our applications and to be able to quickly spin up a new application if we need to. So we didn't have to worry about configuration as much because we kind of had these templates for creating new applications. And then we said, well, wait a minute. I got all these different copies of Windows or Linux or whatever operating system I'm running here, and they're all identical. And this seems like a bit of a waste. And some really smart people came up with the idea of containerization. And so instead of running Windows or Linux or whatever it might be, we're now building our applications differently. We're building them for a containerized engine like Docker. Our applications are being configured to have some certain dependencies. And the dependencies get stored on our server, which is running our containerization engine instead of a hypervisor. And so now each application requires less space in order to get stored on the server. So the server is now able to run more applications with the same level of processing power and memory, etc. So we're able to do a little bit more with our servers using containerization via Docker and things like that. The other nice thing this gets us is that this image, this container that we have for our application, well, the developer can be running the same container on their machine and test it, and they'll be using their development configuration. And then they can pass it off to quality assurance, and quality assurance might test it on their machine and say, okay, this looks pretty good on my machine with my configuration. And then they'll deploy it to a server for testing or for staging or whatever it might be, but they're taking the same container and they're moving it from environment to environment. And so it's less about installing and it's more about plugging the same image in to a different machine, all the way from a developer's machine potentially to production, depending on how your team does it. So this is sort of how the idea of what an application has sort of evolved, talking specifically here about really the application server. Client-side apps continue to change, but this is more about the things that run on our servers. So that's kind of cool. But there's another aspect to it as well, because they're no longer just running in our data centers or in a closet in the server room of an organization. Nowadays, more and more organizations are turning towards cloud hosting. And with cloud hosting, you're using a cloud hosting provider like AWS or Azure or Google Cloud or IBM or Alibaba or something else like that. You're basically renting somebody else's machines. So whether you want to use like a single server or a virtual machine or a containerization engine or something serverless, which is not even pictured here, you're basically renting something from somebody like Azure. And it might sound bad to move from a model where you own the hardware and you control everything to a model where you're basically renting it. But this opens up some other options. When you are buying your servers, you have to make a large capital investment up front. You're the one responsible for making sure that they're up to date with the latest security updates, etc. Versus in a cloud hosting environment, you can make the cloud hosting provider responsible for security updates. You can make the cloud hosting provider, you can take advantage of the ability to upgrade your hardware with a couple button clicks. Say, okay, well, this server level isn't fitting our needs anymore. Let's upgrade to the next tier. You can click a button and then wait a minute, and then you're up and running. And that's not something you can easily do in a self-hosting environment. So this is really kind of what we're talking about when we're talking about modern applications and servers, because it's changed significantly over the last 2 decades, I feel like. So since it's close to dinner time and since it's Monday and I'm in a goofy mood, we're going to be talking about a hypothetical organization here that I'm going to be referring to as Beredit. So Beretta is basically, they're kind of like Reddit, but they decided that they don't want any content on their application that's not related to burritos. And so they decided, hey, we're going to make a web application that has all these capabilities. It's going to be awesome. We're going to hire a crack team of moderators to ban anybody who posts non-burrito related content. And we're going to get a marketing team to really drive up the daily active user count. We're not sure how this is going to make us money, but we're pretty faithful. If we keep going this way, we're gonna wind up in a good place. By the way, I'm having burritos for dinner tonight. Odd coincidence. But that's kind of what we're going with today. And Beretta is still in their very young stages. And they've got 9 users using the application at once, and everything is fine and dandy. Because no matter how small your road is, if nobody's driving on it, it's usually pretty smooth. You're not going to have a lot of traffic. You're not going to have issues. But as you start to get more traffic, as more and more people start using your application, and more importantly, more users start using your application at the same time, that's when you start getting your performance issues. It takes longer to load your pages. You start to have errors instead of seeing the content you're looking for. Sometimes you might even go down, have outages, and you'll notice that users start to use your application a little less than they might otherwise because it's taking a little longer to do the things that they want to do. And so that sort of subtly pushes them away from using your applications. So this is what you'll often see as you start to encounter performance issues for the first time for an application. But let's take a look at how you might handle this. So one of the first things I think an organization should do if they're offering software as a service is that they should install some form of application performance monitoring solution, or APM. And an APM tool, this is New Relic here that's pictured. I've used this the most in my career, so I pictured it because I'm the most familiar with it. But an APM tool gets installed on your server, and what it does is it looks at the incoming traffic that you have, and it looks at the area that traffic went into. So if they're looking at like the top 10 burritos page, for example, and it measures the amount of time it takes for your server to generate a response. And it does that for every request that comes in using really intelligent metrics that it has access to. And it can actually measure the amount of time that your application spends working on the server side of things versus the database side of things versus external API calls. And you can sort of start to see over time, where you're spending your calls, what percentage of your time is going to what. You can start to look at your throughput over time, the amount of requests that you're handling. You can look at, see if there's any errors that occur on specific things. And you kind of get a general idea of what traffic is going on with your application. On top of that, you can tell what areas are hit the most, like where they're spending the most time. If you got one page that's really, really slow, well, you probably ought to focus most of your attention on that. And an APM tool is really helpful when you start to have performance issues and you say, oh no, what do we do? Because when you start to get that panic, you want to be able to make an intelligent decision that's backed by data. And so when stuff looks bad, you start to say, okay, is it one page? Is it all pages? Is it the server? Is it the database? What's going on? And typically, when an organization is just growing, it's typically going to be the server that's the first thing that they really need to start scaling. And so with Beretta, we're going to say that's where most of the early performance issues are occurring. And so we're going to start shifting gears and looking at how we might scale our web servers or application server.
Hey, Matt. So while you're taking a quick drink break, I was going to ask, what other APM tools do you see people using?
Well, a lot of cloud providers will have things installed that will let you kind of monitor your own usage. For example, I've used App Insights before with Azure. It's kind of baked into Azure. I know Rollbar has some things. Raygun has some things. There are a lot of vendors out there nowadays. They all have different capabilities, but most of them are pretty similar. Not all of them support every language or every server technology, so you got to find some that works for you. But I've been very happy with both New Relic and with App Insights.
Okay.
Now, of course, these are paid services generally, or paid by volume. So that's always a consideration you need to make. So the first thing that you probably need to do as an organization when you start to have performance issues is you start to need to look at scaling vertically or scaling up. So that's when you take your small server And you start to say, well, wait a minute, this isn't really keeping up with our needs. Yeah, sure, it's costing me $5 a month, but it's really not meeting the needs of our users when we have a lot of users using it at the same time. So usually the quickest way to restore service and bring your application up to speed is by upgrading your server. So you move from a small server tier to a larger server tier if you are in a cloud hosting environment. Or if you're self-hosting, you might upgrade the memory or processor or something like that, or potentially even replace the machine. But that's the first thing you do, is you scale up. Now, I should tell you that when you scale up your application, you actually need to stop your application and bring online a new version of it on a larger server. So this is a disruptive operation. But if your application is not working at all and you're having a critical issue and you believe that the best thing to do is upgrade your server, that might be a good solution for you. But hopefully you're able to wait until a weekend or an evening hour, some sort of an off-peak hour when you can actually upgrade your server. Just a glance at Azure and how you might do this in an Azure cloud hosted environment. That would involve basically taking a look at your app service plan and picking and moving from one to another one. So I might move from this S1 to maybe an S2, and typically it about doubles your price, which is not something you can do too often, because if you keep doubling your prices, it becomes pretty unfeasible pretty quickly. But early on, when you're at a cheap price, moving to a slightly less cheap price, that's usually pretty doable. And this is good enough to buy you some time to start looking at your performance issues and start putting other measures in place. So usually the first thing you'll do is you'll scale up your server to bring about some sort of a quick restoration of service and to buy you some time to address future needs. But in addition to the pricing issue of this, there are some drawbacks to scaling vertically. So if you think about your business, and if you're running a software as a service or application, it's very likely that not all hours of the day are equal. For example, when I worked in the project management industry, we had a lot of traffic around lunchtime and not a whole lot of traffic around 3 in the morning. It's kind of normal, kind of what you'd expect, right? So you have some hours that are going to be peak hours where you have a lot of users using the system at the same time. And you got a lot of hours where people are not using the system. If all you're doing is scaling vertically, then you need to pay at a level that can handle the highest level of utilization for your server and then a little bit of extra buffer. And so you're paying for the same hefty server that can handle this peak right here at a time when you really don't need it. And so that becomes a little wasteful. And so you start to look at, as you grow, you start to look at other things. You start to say, wait a minute, I only really need a lot of processing power in my peak hours. So what can I do about that? And so instead of scaling vertically or scaling up, you start looking at scaling horizontally or scaling out. And when you scale out, now you're saying instead of one giant server, I'm going to have a lot of little servers. And I'm going to add something called a load balancer. The load balancer, when it gets a request, it's going to say, hey, what's the next server that should get this request? Oh, it's server 1. Okay, here you go. Okay, next one goes to server 2. Next one goes to server 3. And it sort of distributes them round robin style, and it splits up your traffic among all the servers that are registered on your load balancer. Load balancer is typically provided by Azure or AWS or somebody like that when you opt into that kind of a plan, a horizontal scaling kind of a plan. But the cool thing about this is that it's non-disruptive. And what I mean by that is, let's say I'm running with 2 servers on at the moment, and I realize that they're not able to keep up with all the demand that my current level of traffic requires. Well, I can say, hey, Azure, go ahead and add another server to my pool, and it's going to create that server, and it's going to wait for it to get online and running my application. Once it's running my application and ready to receive requests, it gets added to the load balancer. And now the load balancer is going to start sending requests to it. And so it's able to handle that traffic. If I ever say, hey, okay, we're starting to reach the end of the day, I want to scale down now. Well, now we remove it from the load balancer, we wait for it to finish whatever requests it has pending, and then we just get rid of that server. And so this kind of gives us what we call elasticity, where we're able to sort of dynamically add and remove servers as the day goes on, which is pretty cool. And so in order to keep up with your traffic, either your current traffic or the traffic you anticipate, you can set up rules. So you can either manually add and remove servers if you want to, or you can say, hey, every day at 8, I want you to make sure that we're running at 2 servers if we're not at 2 servers already. Or if all my servers at a certain CPU utilization level, I need to upgrade to another server, up to a maximum of 5 servers, we'll say. And if my servers are all pretty calm and we're over a certain limit, let's start scaling back. And so you can start to set up these little rules to dynamically add and remove servers from your server pool. It does take a little bit of time for a server to come up and be ready to handle requests. So there is a little bit of delay, but this can be really helpful for helping you have the right number of servers at the right time. And most importantly, you're only paying for the active servers that you're running. So you pay really based on your needs, which is cool. The business folks like that. They don't terribly like to have things growing uncontrollably.
Matt,
What you got?
dumb question here maybe, but might be real. So what type of things have you seen? It's not just about, like the server part of it, like scaling up or wide.
Mm-hmm.
What type of changes have you seen applications have to make inside to be able to scale?
It's not a dumb question. I actually forgot to talk about it, so I appreciate the interruption. That's great. So your application, it's not easy necessarily to make your application run where there's not just one instance of your application. In order to make this work, you really need your application to not need to know a whole lot about any requests that came before. So your application needs to just be able to work with a shared resource like a cache or a database or something like that. So you can no longer really rely on servers storing data about the prior request. That's the big thing you need to avoid, because you can't predict which server is going to handle your next request. You can't predict that it's going to be one that's handled a prior request related to it. And that can be a big thing for people. It's actually part of like the RESTful conventions that you don't set up your applications like this, but still it can be a big deal for folks to migrate to a scenario where you can scale out like this.
Yeah, it's not easy, right? And at this point, when you're talking about like a server farm, like in production, lots of apps will have these little tie-ins. So like everybody wants to be stateless. It's just difficult, right? And if you and there's solutions out there like like the Redis or different types of caches which are shared, which you can kind of ping a common place, but at this point you need to not just like scale out, but like start architecting your apps so that you can scale out.
I'll tell you what I tell my students: static variables are bad. Static variables are very bad. Static methods less bad. Static variables very bad. All right. So that's basically how we would scale our servers, and that'll work for us pretty well. And that buys you a lot of time as an organization, which is great. And so Beretta is now growing. It's got hundreds of users, approaching thousands of users, and it's continuing to grow. And the business folks are like, "This is great. We solved all our scalability issues ever. Nothing is ever going to be a problem anymore." Until it becomes a problem, and because the server is not the only thing we need to scale. So, assuming we're scaling out right now, we have a problem in that requests come into our servers, but those servers are still talking to the same database server. By the way, in today's talk, I'm basically assuming that most of our databases are relational databases. I will be talking about NoSQL databases later on in the section. But the problem here is that all of these servers are still making requests to the same database server. So even if we've completely solved the scalability issue of our web server or application server, we're now having them all request at the same database. So at some point or another, we're going to have too many requests per second for the database server to be able to handle. So now we need to find a solution for our database server and its scalability issues. Well, the first solution is probably the most obvious, and that's to scale up our server. So instead of having a small database server, we'll have a larger one. And the drawbacks of this are about the same. It costs a bunch of money to move from a small server to a large server. But it costs more than scaling your app server because your app server cares about CPU and memory. But your database server cares about CPU and memory and I/O, input output, and working with your disk. And so you're talking about moving from a hard drive to a solid state drive, and from a solid state drive to a premium solid state drive, and from a premium solid state drive to a large premium solid state drive. And that becomes very expensive very quickly. And so you really only have a couple times you can scale up your database at all over the life of your application, where it really becomes cost prohibitive to keep pressing that button. So you need to be very careful about your databases. So you might be thinking, okay, well, if scaling up isn't going to be the long-term answer, well, what about scaling out? And you might think, well, wait a minute, let's just have multiple database servers. That should fix it, right? Well, don't try this at home, because like I said earlier, the load balancer, we're not guaranteed which server the request is going to go to. So if I'm uploading a picture of my dinner and I'm sending my burrito picture to app server 1, it gets inserted into database server 1, and then I want to go and share it with my friend. Well, when they request it, it might send them to app server 3, which is looking at database server 3, which has no idea about that picture. So this architecture just doesn't work with kind of the way I pictured it here. It doesn't work with a sort of a scaling out approach. We'll talk about a different way of scaling out later on in the section. But the natural, easy way that you might think of scaling out doesn't work the way that you might think. And so as a result, you'll often need to start spending some ongoing portion of your time as an engineering team working on actively profiling your queries, working on optimizing your queries, looking at your database indexes and clustered indexes, seeing what you can do to make your slowest queries better. Because usually there's going to be probably 20% of your tables or less that are responsible for 80% of your slowness issues or more. For Reddit, that might be the burritos table or the comments table or the upvotes table or whatever it might be. But there's going to be a few tables that you really start to need to pay really critical attention to about their performance on an ongoing basis. And this becomes an ongoing necessity that your business sort of has to allocate time for, either on a bug fix basis or on a preventative nature basis, just in order to avoid having to scale up the database server continuously.
Yeah,
there's a couple things that can help. What do you guys think?
I was going to say, like, this is tricky.
Yeah.
Like you said, like you cannot just like keep on scaling your database. And like modern apps and like companies, like we are kind of trying to do everything ourselves. Like the dev loop involves databases and DevOps and everything. But I'm old. Like I'm used to enterprises spending the time to have dedicated DBAs, and they know their database stuff inside out. So before you could push out like new features, like every query had to be optimized. You had to have a plan. And then that makes sense, because you cannot just like keep on kind of stretching a database server.
Yeah. Sam, ask me how many startups I've been a part of that had a dedicated DBA.
Yeah.
It's not very big.
Yeah.
Once you get to a certain scale, yeah. But yeah, it's an issue. But there are a couple of things you can do to sort of reduce your need to focus on this, or reduce the volume that goes into your database. And one of these technologies is setting up what we call a read replica, where you have a primary database that gets read from and written to, and it will synchronize to a read replica database. And this read replica database can only be read from. And so if you have an application that really doesn't need to write from it to that database, usually it's a reporting application or something like that, it can query the read replica database instead of the main database. And that'll reduce the amount of traffic going into your primary database. So that will actually buy you some performance gains there just by setting up a read replica database. So that can be an option depending on your database technologies that you're using, and the types of applications that need data. Because if everything needs to write, well then, yeah, you probably can't do this. Another thing that really, really, really can help is caching. The idea of a cache is, let's say I've got a page that's taking up a lot of resources trying to fulfill. Let's say I've got a page that has the top 20 burritos on Reddit. And I go to that web page and I say, hey, server, give me the top 20 burritos. it's going to say, hey, okay, I'm going to ask my cache. Do I have current information on the top 20 burritos? Oh, I don't. Oh, okay. Well, I'm going to query the database. We're going to pretend this is a really slow query. And when I get my results, it's going to take that and it's going to put it in the cache, and it's going to say, hey, keep this in the cache for the next hour or whatever it might be, whatever time you decide is appropriate for your business needs. And I'm going to send the results back. So that my wife goes on and logs on and she wants to see the top 20 burritos. It says, hey, is this in the cache? Yeah, it is. It's valid for the next 55 minutes. Skips the database server entirely, returns that data from the cache, sends it back. This can dramatically reduce the volume to your database server. This can also dramatically increase the number of bugs you have in your system because whenever anything changes in your system, you need to be updating your cached values or clearing those cached values out. And this can add any number of bugs to your system if you're not careful. So whenever you're designing a new feature, whenever you're making a fix, you need to think about the cache and how much this might affect your cached values. And so this will slow you down a little bit as a development team, but it's also going to buy you a lot of time when it comes to your database server, which is really why you do this. But caching is really maybe the number one thing that you can do to improve your database performance besides scaling up your database.
Matt, what are some of your favorite caching solutions?
Well, I've not actually had the opportunity to play with Reddit. Not Reddit. I've had a lot of opportunities to play with Reddit. Redis. But that's the one I've been the most tempted to try. A lot of what I've done with caching has been very naive caches on a vertically scaled environment. So talking about dictionaries and things like that. But if I had to pick any cache to take a look at, it would be Redis for me. How about you, Sam?
Yeah, same. That's the one. Again, I haven't had a whole lot of experience. You like working in like enterprise teams, like you often do like the caching. You start out doing what is kind of inbuilt, like the SQL Server type of things. But then, like the moment you go to the cloud, that's a whole other type of caching because now you're talking like content delivery nodes.
Yeah.
And our good friend Georgi Shoni is in the chat room. There are two hard things.
Off by one errors. Yep. Yep. I love it.
Yeah. Cache invalidation is hard. It is very hard. Yeah.
Especially when you have multiple versions of your server running. And and keep in mind, my experience has been at small organizations heading to medium organizations, not medium organizations heading to large organizations. So the problems I solve are smaller scale than some of those larger problems with giant caches. But I want to give you all complete exposure of the things that I know about, even if I'm not necessarily an expert on them. So at some point or another, a cache becomes just not quite enough, and you need to start looking at actually solving your database issues on a long-term basis. And that's when you start to look at scaling out the proper way. The way we scale out our database is via partitioning or sharding. Same thing, just different terminology. So when you take a large database that has a whole lot of rows and you start splitting it intelligently into smaller databases. So for example, if I had a business that had customers who had data that's not really related to each other, but they need to store all their data in my database, I might start saying, hey, let's chop our database into 3 databases. Customers that have a name from A to E, they get database 1, F to M gets this database, and everybody else gets this database. And so I start chopping my database up into smaller databases. This can really, really, really work well for you, but you need to do a lot of thinking about this because you're taking existing data, you're adding it to a new database, you're potentially changing the IDs of things depending on how you do this. You need some way of determining which database to work with for any given request. There's a lot of considerations you have to think about if you start manually sharding your giant databases. So this is a giant project that takes a lot of planning and a lot of testing in order to pull off. But it can be really good for scalability because if you get to this model and you start to say, hey, wait a minute, database 2 is really large. Okay, fine. Let's spin up another database just for customers with the name of M. And so you start to be able to partition or sub-partition and stuff like that, which is kind of cool. But this is a giant project. Now, thankfully, some relational databases do let you do this, kind of built into them, but not all of them will let you do this sort of a thing. So kind of keeping things generically and not specific to any one database technology here. Because these things have issues with scalability, like partitioning and sharding, and it becomes a giant project in some cases, this has given some rise to the popularity of NoSQL databases, which, depending on who you're talking to, means either no SQL at all or not only SQL. NO is an acronym there. A NoSQL database is not one type of database, but a bunch of different families and types of databases. So you have 4 basic ones here pictured. You have your key value databases, which are just storing some sort of a value based on a key. So think about this as a map or a dictionary. I believe Redis is a lot like this. You have your document databases, which are kind of like an upgraded version of a key value database that has a little bit more of schema checking and linking and things like that. MongoDB is a big one of these. These often store data in JSON format. You got column-oriented databases. These are interesting. So this is basically, you have a table, but each row in the table might have a different set of columns. So you think about like phone number 1, phone number 2, email 1, email 2, or maybe like a tagging kind of a system. That's where a column-oriented database comes into play. I've not gotten to play with these, but Cassandra is a pretty big one of these. Finally, you have graph databases, which are almost solving a different problem than the other 3. Graph databases are for things that have a lot of relationships. So if you imagine Twitter, I'm on Twitter at IntegerMan. I would be a node in or a vertex in a graph, and I happen to follow Sam, and so I have an edge leading from my node to Sam, and it's a directed graph saying I follow Sam. And thankfully, he follows me too, so he's got an edge pointed right back at me. And there are a number of other folks in chat that I'm sure I follow as well. And you can start to build out this little network of relationships. And you can say, hey, folks who follow Sam are likely to follow X, Y, and Z. And so you start to build recommendations of who to follow. Or if you're Netflix, hey, people who like this movie also like this movie. If you're Amazon, people who put this in their cart also put this in their cart. They're really good for building recommendation engines. Neo4j is a big one of these. Azure has something called Cosmos DB, which can actually be any one of these 4, but it has a Gremlin API that's specific for graph. So that's maybe the best way to get into graph that I've found. But it's really cool for when you need to build like a recommendation kind of an engine. But the cool thing about all 4 of these types is that each one of these really supports scalability. Kind of baked into how they work. They partition very easily. And when things partition very easily, you can easily say, okay, well, I want to store this over 5 machines instead of 4 or 3 or whatever it might be. And so they sort of don't have those problems that your relational databases might have had about scaling out. Now, they also don't have the solutions the relational databases have. Like, they're not as good about enforcing a standard schema. They're not as good about doing complex analysis and joining between tables. Some document databases do have something like that. Some graph databases, you can do some querying like that. But really, that was what relational databases were built on. So you're going to have to look at your own business needs and make an intelligent decision about what makes sense in what type of database. But NoSQL databases can kind of prevent some of your need to shard or partition a giant relational database, which is nice. So Beretta has a problem, and that problem is people are actually using it. And so they've now figured out how to scale their databases. They're scaling up and out, and they've scaled their servers up and out, and things are going well. And their employee count is growing, and they're becoming really, really, really popular. And someday they're thinking about maybe making some money. But for now, they're just happy to build software and have people use it. So now this portion of our talk, we're going to move into more of the random access stuff. This is the more advanced emerging stuff often, but it's kind of cool stuff to talk about. So when you think about relational databases and how they grow and how they scale, there's a certain point when it doesn't matter how much you scale up your database, you're still going to have performance issues. And that's related to locking. Locking is basically when you say, hey, I've got a page of my data or a table of my data or a specific row in a table that I'm writing to. And while I'm writing to this row, nothing else can read from it. Nothing else can write to it. I got a lock on it, and basically there's a line behind me of people who want to work on this. So you have rows that are frequently updated. You can have performance issues with even a really, really, really good database. And so as a result, people start saying, wait a minute, what can we do to avoid this locking? And some really intelligent folks said, well, if updating our rows in our database is slow sometimes, what if we just don't update rows in our database? What if instead of having updates, we just do a whole lot of inserts and we can make a really tall table? They came up with something called event sourcing, which is basically, hey, we're only going to insert into our database. We're not going to do any updates. So everything's an event. I uploaded a picture of a burrito. Great, that's an event. Oh, I made a typo on my burrito upload. I need to fix that. Okay, well, that edit is an event. I'm going to insert it into the database. They're both associated with the same entity, burrito 42, but they're separate rows in my database table. And if I go in there and I add a description later on, that's another insert. I'm inserting another record. And if I ever want to get the current state of that burrito, all I have to do is select things out that have that entity ID of 42, we'll say. I'll pull it out, I'll arrange them in chronological order, and I can basically reconstruct or rehydrate the current state of the burrito according to that database. So this is really a database that's sort of built around a lot of inserts and calculating the current state of things by selecting those inserts out in order and sort of figuring out the current state of things. So very quick for writes. What do you got, Sam?
I'm just scratching my head here. So with this model, like, do you have like data integrity issues? Like who writes first? Like who wins?
I don't know. This is one of the things I've not gotten to play with, but it's new enough that I wanted to sort of share it, just so folks can look into it more if they wanted to.
I don't know anything about this at all.
Yeah.
So yeah,
I would imagine that you would have some issues with really tall tables too. So I would imagine you probably need to periodically clean things up. But this is not something I've been able to do in the real world. So just a caveat there. But I wanted to share with you the basics of event sourcing in case you wanted to take a deeper look into it. But it's a really interesting idea.
So chat room and Shania here is saying most messaging platforms offer order preserving pub sub.
Yep, or a message queue or something like that.
So is this kind of similar to that idea, or like a message queue is a different thing?
Yeah,
right?
it is. Yeah.
Okay.
We'll talk a little bit about message queues in a bit when we talk about microservices. Yeah, there's some really good stuff out there on event sourcing. I'll have to do some Googling, but I might have some of those resources in Teams later on. But I know I've read some really cool stuff about event sourcing. It's just been a while. The cool thing about event sourcing is it dovetails into this other cool thing called Command Query Responsibility Segregation, or CQRS. With Command Query Responsibility Segregation, that's when we say, hey, I want to have one database that's really built for writes. It's going to be really fast to write to this database, which in this case, this might be our event sourcing database, right? And I'm going to have another database that's really built for reads. So the data is going to be stored in my read database in a way that it's a very neat denormalized way of storing it. So I don't have to do a lot of joins to figure out the current state of something. I can just select out rows and it's going to be really quick. And the way these things link to each other is that when an insert happens, it gets written directly to the right database as quickly as we can. And then some form of eventual consistency will eventually make that write operation present in the read database. So you might have a nightly job, you might have a message queue that communicates to something else that inserts it or updates your read database. But some form of consistency will make sure your read database is up to date. So you have one database that's really built for rapid writes and another database that's built for rapid reads. And you have something that kind of marries the two of them together. But there's often a lag where the data that you're reading might not be the correct data. So this might not be good for all systems, But if this is okay for your needs, this can really, really work and solve a lot of performance issues. You might not even need a cache at all if you're using something like this. So this is another one of those things that I've not been able to play with too much. There's a lot of cool frameworks out for it and a growing number of them. I would encourage you to dig into it more before you try it out in the real production system. Same with event sourcing. But these are some really interesting newer things that people have been talking about the last few years, which is really intriguing about how we build our software. So now let's segue a little bit and talk about the buzzword of the last decade or so, or maybe the last half decade, and that is microservices. Sometimes you can't throw a stick without bumping into a couple microservices, it feels like. The idea of a microservice is instead of a very large monolithic application, you have a lot of smaller microservices. And these are just smaller portions of an application that each have their own database that's using whatever database technology makes sense for that service. And they communicate to each other somehow. In this picture, they're all making direct API calls to each other, which has some drawbacks that we'll talk about in a second. But microservices are a solution that exists to solve a few specific problems. And those are problems that exist with our larger monolithic applications. So when you have a large application that needs to scale, it can be hard to scale it because certain parts of it might need to scale at a different rate than other parts of it. So your inventory microservice might need to scale differently than your billing microservice might. So that might be a case where you might need to pull out another service. But often microservices are a solution to a people problem. You have too many people working on a large application. They're stepping on each other's feet. It's hard to communicate. It's hard to coordinate. It's hard to manage your projects. Let's split our giant application into smaller applications and have teams dedicated to each one of these smaller ones. So microservices are almost a technical solution to a people problem, but it can make sense at a certain scale. I've never worked in an organization of that scale before, but if you have, and if you're feeling those pains, microservices could be a valid solution for you. But you have a lot of issues with them potentially, because when you start having all these different complex pieces, you need to be aware of how they talk to each other and how they communicate with each other, and how an entire request flows through all of your systems. It becomes harder and harder to debug what's going on. It becomes easier for bugs to hide in the cracks, for teams to have communication issues with each other. There's a lot more ways that things can break down. And so you start to rely on a lot more of logging and monitoring. You start to rely on a lot more automation. In fact, in order to have microservices successfully, you really need a certain degree of automation at all in order to really be able to update these databases and these applications and coordinate your updates with other teams. So microservices are not something that you should consider unless your organization has a certain degree of size and maturity, because the drawbacks to it are just going to outweigh any benefits you get from it. Yeah, it's cool to put on a resume. Yeah, it's cool that you get to use a database over here and the other guys get to use this database over there. That's nice, but is it worth all the drawbacks that you get with microservices, such as not being able to understand as easily how something flows through all your systems, not being able to think about your entire system as easily, more and more difficult times bringing on new developers, things like that. So all this stuff does have costs, and so there's trade-offs that you need to be aware of. Additionally, once you start getting into an environment like this, you need to think about, hey, what happens when something goes offline? Let's say my app service can't talk to my auth service. Let's say my inventory's database is offline. How should we handle this? Do we tell the user try again? Do we retry at a later date? What's the cost? What's the answer to this stuff? And if you're just doing something like I've pictured here, where one service calls to another, well, each one of these calls takes a little bit of time. And so you're just slowing down the overall experience for the user anyway. So microservices have their own drawbacks, but they don't have to be directly tied to each other like they are in this picture. You can introduce an event-driven architecture or a pub-sub architecture. I think I saw a highlighted comment a while ago on that. In a pub-sub architecture, you have certain services that publish events to event brokers. So a shopping microservice might expose a item added to cart event, or a purchase event. A billing microservice might expose a billing complete or billing bounced or something like that events. Other services can then say, hey, I care about that particular event. Notify me whenever one of those events happen. And so you start to get into this little bit of a event broker mentality where everything is just publishing and subscribing to events, and they're not really aware of each other. They're just aware of these events and how they interact with each other. So in this kind of a model, you have some things that are publishing events and some things that are subscribing to events. And the billing service might not know that the shopping service exists. It probably does, but all it cares about is I want to know when a purchase was made so I can bill somebody. And so you say, hey, event broker, I want to subscribe to this event. The event broker says, cool, I got a message queue just for you. So whenever I get a request to purchase a product, I'm going to add an event to your queue. And whenever you're ready, just take the next thing off the queue from the front of the queue. Remember, queues are, queues go front to back, just like we're used to there. And the cool thing about this is that you can now sort of scale your billing billing microservice. So the billing microservice will take the next thing off of the front of the queue, and it's going to process it. And if it starts getting behind, well, you can scale it vertically, or you can build another billing microservice, and you'll start to accelerate the number of things you're pulling off of your queue. So you can start to scale these independent services independently. The other cool thing is if your service goes offline, well, that's fine. As soon as it comes back online, it'll pull the message from the message queue. It'll process it. It doesn't matter if it happens now or if it happens in 5 minutes. It's going to come back. So you start to get a little bit of fault tolerance with this kind of an architecture. Of course, you're probably paying a decent amount for the things that are enabling you to do this. And you have to debug issues with these kinds of architectures. But this can really decouple your microservices from each other, add some more fault tolerance, and give you a little bit more room in case things go offline or are slower. But they're not really appropriate for if you need like an immediate response to a request from a user. So you have to think about what you really need. You have to design your systems to kind of kick off an event and for that event to kind of complete at a later point in time, etc. But at a certain scale, this can absolutely work. So my main moral for you all is all of these architectures work. All of these enable us to deliver pictures of burritos to hungry users. But not all of them are appropriate for all teams. If I'm a small startup and this is just me working on my evenings, this is probably just fine. A monolithic application that I scale vertically as I need to, that's great. If it's no longer cost effective for me to scale vertically, okay, let's start scaling out. I'm going to design my application to let me scale out as I need to from the beginning, but let's scale out as we need to. At some point in time, it might be healthy to split my database into 2 separate databases, or to start looking at NoSQL or partitioning or something like that. And then if I get to be a gigantic corporation with too many people on the team to really work with each other, all right, well, let's start looking at microservices. But all of these are appropriate solutions for different types of organizations at different scales. So my recommendations are, early on, make sure you have some sort of a monitoring solution in place for when things do start to scale. Don't be afraid to scale up early on to buy yourself some time. Start getting in the habit of optimizing your queries, paying attention to indexes. On the front end side of things, you probably want to take a look at minification, maybe CDNs, content delivery networks, things like that. Once you start getting a sustained level of growth, that's when you're looking at scaling out. You're looking at caching in the places where you need it most. You're looking at planning ahead around your databases, etc. I'd also heavily recommend you put rate limiting in place in your APIs so that people don't call your APIs with too many requests in a given minute and overwhelm the system. I've seen this happen a number of times at a number of organizations, either intentionally or unintentionally. You almost always need rate limiting before you think you need rate limiting is my experience. And I have some horror stories I could tell you on that too. At the advanced side of things, you need to really put a permanent solution in place for your database, whether that's splitting it up into different database technologies, investing in a form of a relational database management system that can automatically scale out, or manually partitioning things, moving to NoSQL, whatever you might need to do. You need to be automating, really should be automating throughout this whole process, but you'll need some really advanced logging and automation once you hit the advanced size to the point where you need microservices and event brokers and things like that. So these are kind of my guidelines. There's no firm rule about which one you're in, etc. But think about where you are right now, where you're about to be, and build your applications around that. So if you want to play around with some of these concepts, my recommendation to you is to do two things. And I'm the Microsoft guy, so I'm going to push you in Microsoft's direction. But first, I'd recommend you create a free Microsoft Azure account, because you can only have one free one, and it really has to kind of be your first account. So sign up for that. It's like 12 months of free services plus some credits in your first month as well. And then Microsoft also has some really cool things on Microsoft Learn. That's text and video content related to a lot of their services, etc. Some of this is geared towards certification, but a lot of it's just really helpful stuff for learning their services and how to use it. A lot of them also, the newer ones, will have sandboxes that you can use and play around with these services without incurring any charges at all, which is really awesome. If you want to read a little bit more, my recommendations for you are a couple books. Fundamentals of Software Architecture by O'Reilly. Really anything in this White O'Reilly series nowadays tends to be awesome. But this is maybe the one I would start with. This is talking more about how you architect your code, etc. A little bit less about the overall scale of things, but it's still a very, very, very good book. More intermediate, advanced, but it's a very good book. Web Scalability for Startup Engineers is fantastic as well. Definitely recommend that one. And actually, this whole series of talks that I've given this year about this stuff has been because I've been writing a book as I can about application scalability. So if you're curious about that book project, there's a link, but newdevsguide.com will help you out, help you learn a little more there. Let me know you're interested. It helps me focus on that with all the other projects I have going on, etc. But I fit that in as I can as I'm teaching in the evening.
So I was going to say, like, damn, we know that third guy.
Yeah.
I didn't know about this news already.
If you couldn't tell, Sam.
Yeah. No, that's really awesome. It takes a lot of work to write a book. A lot of work.
Yep. Finally, I'd be remiss if I didn't plug. So if you're ready to learn software engineering, you know somebody who is, check us out at techelevator.com. This is my boss, Vinny. You can email him, tell him what a bad job I did today. If you're looking to hire, we always have qualified candidates. We still have a few out there from last cohort. If you wanted to hire somebody in about 6-7 weeks or so, I'll be graduating another class, and they're awesome. So just get in touch with us. We also welcome volunteers if you want help with mock interviewing, serve on a panel, etc. Just talk to us. We'd love to continue a conversation. We're very active in our community, especially in Central Ohio. But also the other cities that we're in as well. But I'm a little biased towards our Columbus team. If you want to follow me on Twitter, I'm at Integerman. You can also follow my other projects if you go to matteland.dev. There's my email there and our book link. And I'm happy to answer any questions you might have.
Okay, I got two right out of the gate. One is, like, you talked about the containerized model.
Sure.
Going to Docker.
Yep.
Do some of these scaling techniques work seamlessly on containerized solutions?
Yes, you can host your applications in containers. You can create new containers as you need. So like you think about scaling out, that will work in a container kind of system.
But you still might have like the database that you're talking to, depending upon if you have it like in a microservice type setup where you have the database included as compared to calling something that might be the bottleneck.
Yep, that's true. You need to partition your stuff, decouple it a little bit from the database. So in a container for running a web server, for example, you'll probably give it a configuration setting for where to go find the database or databases, whatever it might be. And then you're just using Azure container instances or Kubernetes or whatever you might be using to scale out. And that'll help you out a little bit.
Yeah, or you say said the K word. Kubernetes
I did.
it's wonderful. It's just like some topics are just difficult to express.
Yes.
I'll say that.
I could have said K8S instead, but that would have been better.
Oh, and so chat room, and by the way, this is your chance to ask any questions of Matt. And Jen Wosti, if I'm saying that right, has a question. So, doing a startup currently, do you offer architecture review services?
I have no time for that. But hit me up on Twitter, and I might be able to find some folks who could help you with that. Because I know some really awesome people who have more time than I do.
Yeah, no, and architecture, it's difficult because like it takes years and years of experience to understand the moving pieces, and a lot of the architects work on like bigger tech companies where they are solving bigger problems. So there are architectural like services on hire. I just don't know.
Yeah,
I don't know any.
But always happy to answer questions on Twitter, without billing you or assuming any liability. All that.
No. Sometimes all it takes is just like picking a set of brains. And I think that's how like the dev community we have is just like we're fortunate. We learn from each other.
Yeah, and sometimes you just need to know that something exists so you can look into it more.
Yeah, absolutely. All right, so I'm going to allude to something you mentioned in terms of the rate. Rate planning, but just overall, with all the architectures that you have seen, any horror stories that you want to share, like without taking names?
Okay, I got one.
Tell us a good story. Okay,
I got one story for you. This is what I call the accidental denial of service attack. We had a dashboard that displayed a lot of really nice charts, but they required a lot of data that was harder to generate. A lot of aggregation, etc., going on. So it was maybe the most important page in our application for a while, the most expensive page to render too, just in terms of server database time. But it worked fine. It didn't take very much time at all to generate that page, maybe 100, 200 milliseconds, something like that. So maybe a little bit of a noticeable load, but not too bad. But we had a customer who says, you know what, I really like this dashboard page. I really would like this to be up and auto-updating itself, etc. So I'm going to write a browser plugin to automatically refresh this page every, let's say, 10 minutes. And so he writes a JavaScript plugin, and he says, okay, on interval, I want you to call this. But he either forgot to give it the interval parameter, or he set it to 0. And so what that does is every millisecond, it made a request out to our server for the most expensive page that we ever had. And so something that took, 100, 200 milliseconds, we're now serving that up 100 times in 1 second. And so it didn't matter how many servers were running, they could not keep up with this. And so we actually had to ban this user because we didn't have rate limiting in place. If we had rate limiting in place, it would have said, hey, you can only make a certain number of requests within 1 minute or 10 minutes or whatever we determined it might have been. And then it's going to say, hey, for your API key, you are banned from making further requests until the next window arrives. It'll give you back a 429 status code, too many requests. And that would have basically short-circuited that issue for us. So we didn't have to figure out which user was causing us and ban them. Because it basically brought a production environment to its knees for all software as a service or customers that were using that shared server instance. So that's my horror story there.
So like it was a customer that did something, but you should have been ready. Essentially, is what you're saying.
we should have been ready for it. But we didn't have rate limiting in place. But a bit after that, yes, we did. Absolutely, we did. So, you live and learn. But at some point, somebody's going to attack you or accidentally make a plugin like that and maybe be a little bit too aggressive on it, even during testing, potentially. Because I don't think he thought his plugin was done. It just, the way he was testing it, it just crashed everything for us. So code defensively, put rate limiting in place when you start to have sustained usage and you can afford the engineering time for it. But it's really worth it, let alone if somebody's trying to give you a denial of service attack.
Yeah, and then the moment like you put your stuff out on the internet, like be ready for for the bots and these denial of service attacks to come. So you just have to, I mean, that's a whole other like application security topic, but it's going to happen.
Yep. Yeah. I have my own personal sites out there on Netlify. It's not a huge deal if they go down, but that's very much different if you're, somebody's paying you for your services.
Right. And one of the aspects you talked about, like the database sharding thing, it is really hard. Like once you start having a production database for a few years, it is just really difficult.
Yeah.
And we have seen like really bad stuff happen, but it's not well thought out. Yeah. So anyways, this was great. This was great, Matt. Like you shared in an hour, like your experiences over like probably 2 decades of doing software.
And software didn't stay put during that time either. So yeah,
this has been amazing. So thank you for taking the time. Hopefully you get to enjoy a nice burrito. You have earned it.
It's not here yet, but eventually.
Eventually. All right. So chat room, Hintaya, George Ishonia, Joan Weste, everybody else, thanks for hanging out with us. This is the slide where you can find Matt. I actually love your Twitter handle, Integer Man. How simple and elegant.
Yeah.
So go find Matt if you have any questions. He's always out there trying to help. So thank you all in the chat room. And thank you again, Matt. I appreciate it. And for those of you who are in the user group or came in through Meetup, you may have seen the link. So we have like 15 minutes left. Hold on. You have had like folks staying up here for you. Look at that. John Roste is 1:15 in the morning in Denmark, worth the time. So thank you, gents.
Really, thank you.
That's really appreciated. So thank you for your time, Matt. All right, so if you came in through the Meetup, I think we got like 15 to 13 minutes left, but we can go hang a little bit offline on Teams if you're still up for it. If not, no biggie. But we'll see you here next month for another edition of the user group. And in the meantime, come and join us. Like for the Code It Live folks, come and join us throughout the week. We code .NET and JavaScript all through. So come hang out, and that's it from us for the user group this time. All right. So thank you, and stay well, stay productive, and bye for now.